Okay guys, I just wanted to do a couple of more examples from our notes so you can refer back to this. Remember, your ultimate goal while you're solving these is to get your bases to be the same number. Sometimes that can be tricky. You have to think. Right off I kind of thought maybe 4, because 4 squared is 16, but 4 raised to any exponent cannot be 8. So that's not going to work. So we're going to go back down one further from 4, and I do know that 8 is 2 cubed, and 16 is 2 to the 4th. So I haven't changed their value. I've just rewritten how they look. If you already have an exponent in existence when you created this new one, you're going to multiply it to the old exponent. Once we get our bases to be the same, we're going to cross them off. And I'm left here with 12x equals 3x plus 6. And then I'm going to subtract, let's see, 3x from both sides. So we get 9x equals 6. Divide by 9. And we get x equals, when I reduce it, it's going to be 2 over 3. So hopefully the solving part is not what's giving you a problem. It's more finding your like bases. So that was 12 from the notes. I want to go ahead and do 16 from the notes, give us some more options. When I'm looking here, 243, I had told you on the front, hopefully you made note of that, of some of our different exponents available to us. But 3 to the 5th is 243. And we already have the x minus 2 in existence, so we got to write it like this. 27 is 3 cubed. And the 2x was already there. Once you have like bases, they cancel, and you're left with what's left over. 3 times 2x, 6x equals 5x minus 10. I'm going to move the 5x over, and I get x equals negative 10. So the hardest part is coming up with what exponents will work. So look at the smaller number and see if there's something you can do. 27, the only way we could get that was 3 cubed. So then I see does 3 raised to some exponent work with 243. And you just got to guess and check and use your calculator and try a few of them. So from 16, I want to go on to 17 because it looked a little bit different. So in looking at 17, I got 2 4 bases over here, so I asked myself if I could make 64 using a number and a 4 and an exponent, and I can. And I know 4 to the 3rd is 64. So I'm just going to rewrite it this way. Now, I have 2 bases that are the same, that are multiplying. That means I add their exponents. I don't want you to forget there's actually a 1 right there. So this will be 1 plus 4x. So we got 64, no, sorry, we have 3 equals 1 plus 4x. We're going to subtract 1 from both sides. 2 equals 4x, divide by 4, and 1/2 equals x. Right? Now, the last one I want to do is number 19. I see a 7 base here, and I see a 7 here, so it starts making me think, can 49 be rewritten with the 7? And it can. That's actually 7 squared. So we got a couple things we want to go on here. I want to move this 7 to the 1 up. When there's a 1 on top, we can easily move this up. It's a positive 1 there, so when it moves on across the fraction bar, it becomes negative 1. Equals 49 is 7 squared. Plus the exponent that was already in place, times 7 is already the base that we want. All 3 of my bases match. We're going to cross them off. I get negative 1 equals 2x minus 10. And when you multiply like bases, you add their exponents plus x minus 9. So I've got some like terms here. I've got 2x and x is 3x. Negative 10 minus 9 is negative 19. I'm going to add 19 to both sides, and I get 18 equals 3x. Divide by 3 on both sides, and my x equals 6. So hopefully seeing a few more examples that you can stop and start at your pace will be helpful to you, and we'll see you tomorrow.